few more examples based on partial differential equation for the given function. So I have taken the next question is form the PDE by eliminating the arbitrary function of the equation z is equal to f of x square plus y square. You can see here we have only one function, means we need to differentiate this equation with respect to x and y, because here x and y are the two independent variables. So given z is equal to f of x square plus y square, give equation number 1. So differentiate one partially with respect to x and y. So with respect to x, what happens here? Dou z by dou x. So f of x square plus y square with respect to x partially it will become f dash of x square plus y square, and differentiation of x square plus y square will be 2x plus 0, because 0 is because what here we are doing partially with respect to x, so y will be purely constant, which is 0. So therefore this equation can be written as what here? 2x, so this dou z by dou x as p, 2x before f dash of x square plus y square. Give equation number 2. Next, according to the differentiation, now we have to go for equation 1 supposed to be differentiate partially with respect to y also. So therefore dou z by dou y, so this will become dou z by dou y is equal to f of x square plus y square will be f dash of x square plus y square into partial derivative of the bracket x square plus y square will be 0 plus 2y. So on rearrangement we'll get, so this is nothing but symbol of q is equal to 2y before this and f dash of x square plus y square. So once we get this, give equation number 3. So from 2 and 3, so how to eliminate? You just see how many terms are there on the right hand side in both. If it is only one terms and easily possible to cancel, then we go directly. So on dividing 2 by 3, so equation 2 divided by equation 3, so what happens? Left hand side divided by left hand side of 2 and 3, that is p divided by q. Right hand side divided by 2 of right hand side divided by 3. So what happens? 2x f dash of x square plus y square on the right hand side and divide. So cancel 2 the f dash cancel. So we have eliminated the function f here. So we left with x by y from this, so which is nothing but p upon q is nothing but x upon y, cross multiply, py is equal to qx or py is equal to qs is equal to 0 is nothing but the required partial differential equation of the given equation z is equal to f of x square plus y square. So next we will see the example as z is equal to e raised to y into f of x plus y. We have to eliminate this function f now. So given question, e raised to y into f of x plus y, equation number 1. So this z is independent variable of two variables, that is x and y. Means we have to differentiate this equation number 1 with these two independent variables x as well as y. So differentiate one partially with respect to x, will get e raised to y, which is constant, keep as it is. We have to differentiate the function containing x only. So here no functions are there of x, so this you treat as a purely constant, keep e raised to y as it is. Only we have to differentiate f of x plus y, which will become f dash of x plus y into differentiation of the bracket x plus y is 1 plus 0. So on rearrangement, so this is notationally p e raised to y into f dash of x plus y, give equation number 2. Now we have to differentiate equation number 1 again partially with respect to what here? Y. So if you differentiate with respect to y, right hand side, so we have two functions, product of two functions, that is e raised to y and f of x plus y, both having what here? This also having y and this also having y. So in such case we need to go for product formula, but with respect to x this will be treated as purely because no function of x here. So at that time what happens? No variable x, so at that time you have to treat this one as constant. But with respect to y, for this situation, here also we have y and here also we have y, so we need to apply product formula. So therefore keep e raised to y as it is, keep the bracket f of x plus y as it is. According to this situation, f of x plus y I have kept as it is, and partial derivative of y with respect to y is e raised to y itself, plus now keep e raised to y as it is, and partial derivative of f of x plus y is what here? F dash of x plus y, and bracket of bracket differentiation is 1, you leave it. So on simplification, so this e raised to y into f of x plus y. E raised to y into f of x plus y is nothing but z. I have replaced this as z here, z plus e raised to y into f dash of x plus y. So which is nothing but this result is nothing but e raised to y f dash of x plus y is nothing but p. So I will replace this f dash of x plus y as equation number 2, which is p. So z plus p, which is nothing but q, is equal to, or I can say that p plus z is equal to q is the required PDE. Next question is, z is equal to x plus y plus f of xy. So equation number 1, again you see that this z is a function of two independent variable x and y. So differentiate one partially with respect to x and y. So with respect to x partially, so it will become dou z by dou x. Derivative of x with respect to x is 1. Derivative of y with respect to x is 0 plus as it is. So we need to go for partial derivative with respect to x for the function into xy. So f dash of xy, and differentiation of xy is what here, partially is what here, 1 into y. So on simplification, 1 plus this y will come before, so y times f dash of xy, or this 1 you shift to the left hand side, so it will become p plus 1. You shift this one, it will become, so I have mentioned here dou z by dou x as p, and this 1 and y of f dash of xy, you shift to the left hand side. So if you shift left hand side, it will become p minus 1 is equal to y of f dash of xy. Give equation number 2. Similarly, if you differentiate z with respect to y partially, dou z by dou y, partial derivative of x with respect to y is 0, y is 1 plus f of xy will become f dash of xy into x is a constant, partial derivative of y is what here, 1. So it will become 1 plus x into f dash of xy, or which is nothing but dou z by dou y is nothing but q is equal to 1 plus x into f dash of xy, or you shift to the left hand side, it will become q minus 1, and we'll get a equation number 3. So on dividing 2 and 3, we'll get left hand side p minus 1 divided by q minus 1 is equal to y of f dash of xy divided by x into f dash of xy. So f dash of xy cancels. So left with y upon x, cross multiply x into p minus 1 and y into q minus 1, which is nothing but a required PD. You can open the bracket or else you can keep as it is also.